Hello, welcome to lesson 3.1, Significant Figures, Part 1. We're going to look at identifying significant figures. So here are our rules for significant figures. Depending on previous courses you've taken, it may be review. If you have not taken, for example, a physical science course, you may not know them. So significant figures, they are the number of figures that are known with some degree of reliability. That is like the textbook definition. So we have four main rules here. Here you are. These are our four rules for determining how many significant figures there are. In part 2, lesson 3.2, sig figs part 2, we will talk about how to use sig figs in addition, subtraction, multiplication, division. So let's go ahead. Let's talk about them. So we'll do this one. Let's take the number, let's take 1.234. So this has no zeros, so we don't have to apply our three other rules. This just has 4 digits. We don't need to worry about the decimal point since there are no zeros. Since they are all non-zero digits, there's 4. If we go back to over to our rules here, all non-zero digits are significant. So, for example, if we take 1.2, 1.2 has 2 significant figures, or we call them sig figs for short. But let's apply our our zero rules now. Let's go ahead. Let's do zeros between non-zero digits are always significant. So if we take the number, let's say 301. We know that 3 and 1 are significant, so that's 2 already. But that 0 is between 2 significant figures, which means there would be 3 significant figures here. Oh, if we take 1002, both of those zeros are between non-zeros, so we know that there is 4 significant figures here. Now let's talk about some of our exceptions. I'm going to go ahead, clear the board here. So the best way to remember our zero rules are always, sometimes, never, or always, never, sometimes. So here, I'll go ahead. So we have trapped, leading, and trailing. So trapped, those are our zeros between significant figures, are always significant. Leading, if we go back to our rules over here, leading zeros are never significant, even if there is a decimal place. And then trailing, go back to our rule over here, trailing zeros are sometimes significant. And that depends on decimal places. Let's go ahead, do a few of these as practice. So let's start with our never rule. So let's say we have 0.001. And units don't affect significant figures. So even if we were to say this was grams or something like degrees Celsius, does not matter. Oh. So this would have one significant figure because the zeros are leading, they aren't significant, and then we just have one non-zero. Then we have 0.012, they're leading. We know that it's two significant figures because of our non-zeros. Let's talk about our trailing rules now. So I'm going to go ahead and clear the board here. So let's say we have 0.200. So if we were thinking about this in just a mathematical way, we would automatically in our heads just round that to 0.2. But you don't always want to do that because of measurement uncertainty. We will talk about that later in this unit. So I'm going to go ahead and change colors here. So we know that one is not significant because that is leading. We know, we'll go ahead and circle this. 2 is significant. It's not a 0. However, these two zeros are trailing after a decimal point, which means they are significant. So go ahead and circle those. That means we have 3 significant figures here. So we can play around with this rounding with significant figures a little bit. So let's say we'll cover scientific notation more in depth later on. We'll understand how to work with it mathematically and such, but let's say we have 50,599, and we wanted to round this to 4 significant figures. So we could write that as, we could round that to 50,600, and that would be 3 significant figures. But we can play around with scientific notation a little bit. We can say that 5.060 times 10 to the 4th, that has 4 significant figures because we ignore the scientific notation numbers when dealing with significant figures. We only look at this. However, this wouldn't be fully correct because this would end up rounding, I believe, to 506,000. But that is an example of how you can play around to play around with scientific notation and significant figures. So once we cover scientific notation a little more in depth, it'll make a little more sense. But let's go ahead. Let's do some practice. So let's go ahead. Let's do some of these. So number 1, 956. This is pretty easy. There's no zeros. They're all non-zeros. We got 3. 3. Then we have 2.1390. So we know there's at least 4 because they're non-zeros. And then that 0 is trailing after a decimal point, making us have 5 total. Number 3, 4,390. That 0 is trailing, but it's not trailing after a decimal point, so there's only 3 here. Number 4, that 0 is leading. It is insignificant. And then we have 5, non-zero, and then those 2 zeros are after decimal point, but they're trailing. So that means we have 3 significant figures. Number 5, 500. Those zeros are trailing, but they're not after a decimal point. So we only have 1 significant figure here. So again, I mentioned that with scientific notation, you only look at this side. So this would have two significant figures when it's expressed in scientific notation. Number 7, 0.40001. All of those zeros are trapped, so they all count as significant figures. That leaves us with 5 significant figures. Number 8, 1.7 times 10 to the negative third. We only look at this side. So we have two significant figures here. Number 9, this one's a tricky one. So 650 point. There was nothing after the decimal point. But that decimal point makes it so that that trailing zero becomes right before a decimal point, making it significant. So this would actually have 3 significant figures, and that is how you can play around a little bit with rounding. We have number 10 here, 4.150 times 10 to the negative fourth. This would have 4. That 0 is trailing after a decimal point. Leaves us with 4. Any others I want to do? I don't think so. So that is significant figures part 1. In lesson 3.2, we will cover how to use significant figures in operations, mathematical operations.